Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. Dear viewers, in today's lecture, we are computing the arithmetic mean from discrete data by shortcut method, a step deviation method, or a coding method, the one that has been used for continuous data already. So today we are doing the same for discrete data. In today's lecture, we will use the same discrete data that has already been used in one of the lecture for the computation of the arithmetic mean by direct method. So let's start the lecture. This data has already been used in one of the lectures, that is computation of arithmetic mean from discrete data. So let's start. This is a discrete group data or a discrete frequency distribution because the values of the variable are in discrete form and the corresponding frequencies have been given. Now, by direct method, we have already computed the arithmetic mean from this data set, but today we are going to compute the arithmetic mean by a shortcut method or step deviation method or coding method, the one that has already been used for continuous data. As in the case of continuous data, after determination of x, we took a value from x as the provisional mean or arbitrary mean, and then subtracted that arbitrary mean or provisional mean from each value of x, and then divided that difference by the class interval or the gap between two consecutive values. So in discrete data, what we will do, we will take the provisional mean. So as we have discussed in that example of continuous data, usually we take a value of x as the provisional mean that has maximum frequency. So in this data set, this 10 has maximum frequency, this 10 has 20 frequency. So we take such value of x as the provisional mean. So this would be the provisional mean or arbitrary mean, so I will denote it by A. Now for this data set, what we will do, we will find difference column, that is difference of x, D for difference, x for x, so difference of x. So what do I mean? Now I will subtract this provisional mean, this arbitrary mean from each value of x. So 2 minus 10, 4 minus 10, 16 minus 10. The resulted values are, so this is difference column. Now the formula for this would become, now if you look at the formula, so there is A, there is summation f dx and summation f. So this quantity is already here, this A is here, this summation f, if we add this column, so we will get summation f. So this would equal to 100 as the total is 100, but we don't have this quantity right now. We have dx, we have f, but we don't have its multiplication. So now we will multiply both of them. If, what do I mean? We have f column individually and dx column individually, but we don't have its multiplication. It shows its multiplication. It shows the multiplication of f and dx. So in this setup, we don't have f and dx. So we will multiply these two columns, or we will multiply the corresponding values of these two columns. So by multiplication, what we will get? We will multiply this by this, so it will give us minus 48. We will multiply this by this, so it will give us minus 66. Similarly, it will give us minus 60, and the last one will give us again 36. So if you add, so this will give 100. Now putting these values in this formula, x bar would become a is equal to 10 plus, this gives us what? Minus 100. So this will be minus 100 and summation f also equals to 100. Further simplifying, it will be 10 plus, it will give us minus 1, and finally it will give us x bar as 9, which is equal to the one that has been computed by direct method. So now this is another way of computing arithmetic mean from discrete group data or from discrete frequency distribution. Now one more thing I will add is I have mentioned if these differences are constant, I mean distance from 2 to 4, distance from 4 to 6, and all the distances are equal, as in this case these distances are equal to 2. This distance is equal to 2, this distance equals to 2, this distance, and all of them. So in this case, as we have done in the continuous group data, we can go one step ahead. So in this case too, we can compute u column by the same coding, x minus a divided by this I. You can see I over here. Actually this dx equals to x minus a. If we focus, so actually this dx is already equal to x minus a, because from each value of x, a has been subtracted. So actually this dx is equal to x minus a. Or you can put over there, instead of x minus a, you can put dx. So we can code u like x minus a divided by I, as we have done above, or we can code u like this, dx divided by I. Both of them are equal. Now, as we have used u, so the formula in this case will become exactly equal to the one that has been used in continuous case. So we are writing the formula. X bar would be equal to a plus summation fu divided by summation f multiplied by I. So the formula in this case is exactly equal to the coding formula for continuous case. Now, if we focus upon this formula, so what do we need? We need a, we need summation fu, we need summation f and I. So a is already there, summation f is already there, and summation fu. Summation fu is not available. So now we will find u column. What is u? X minus a divided by I. So this is x minus a column. Now we will construct u. So if we focus upon u, so x minus a is in the numerator, and this has already been calculated over here. So we don't need to calculate it again, but what we will do, we will directly divide it by 2, so we will get this column. Because x minus a has already been calculated over here. So we don't need to compute it again. So dividing minus 8 by 2, which 2? The difference of these two. By these two. Why do we divide minus 8 by 2? Because the difference between these two values is 2. So minus 8 divided by 2 will give us minus 4. Now minus 6 would be divided by 2. Why? Because this difference is again 2. So it will give us minus 3. Similarly, dividing minus 4 by 2, because again the next interval is also 2. So as I have told you, if these differences are identical, so then we can go to this step, one step ahead. But if these differences are not equal, so then we will stop over here, and by this method or in this formula we will find the arithmetic mean. So as the differences are equal, so that is why we have been moved one step ahead. Okay, this would be minus 2, this would be minus 1, this would be 0. So as I have told you the trick, that we can directly place 0 against the arbitrary mean, and for all those values which are smaller than the arbitrary mean, we can directly place negative integers against each value. For example, 10 is the provisional mean or the arbitrary mean, so for 8 we can place minus 1, for 6 we can place minus 2, for 4 we can place minus 3, and so on. This will automatically equal to what we have computed already. Okay, after 0 we will apply the same trick. So Directly we are writing 1, 2, and 3. So let's compute FU. This is F and this is U. Now this minus 4 will be multiplied by 6. So it will give us minus 24. Do remember, sometimes students get confused because they are multiplying irrelevant columns. So look at, this is F and this is U. So this is U column and this is F column. So just multiply the corresponding values of these two columns. First value with the first one, second value with the second one, and so on. Now we will multiply minus 3 by 11. So you will get minus 33. Similarly, minus 2 by 15. So you will get minus 30. Next we will get minus 16 and finally 18. After addition, we will get minus 50 as answer for summation FU. Now we have all those numerical values which are needed for this formula. So now putting those values in this formula, x bar would become A is 10 plus summation FU. Summation FU gave minus 50 and summation F is 100 and multiply by 2. So this would be 10 plus, if we cancel it out, so it will be 50, and if we cancel them out, so we will get again minus 1. So the answer is again 9. So now we have been reached to a conclusion. If we apply the direct method or the shortcut method, step deviation method or coding method, so in all cases we can get identical result. But what is the use of step deviation method or coding method? It helps in computation. So this is the only reason that why do we use shortcut method or step deviation method or coding method. So now we can see by all methods we got the same answer. So it means methods of computation do not affect the answer of the arithmetic mean. So it was all about the arithmetic mean from discrete group data. Hope this video have made your concept clear about the computation of the arithmetic mean by either direct method, step deviation method or coding method. Thank you for watching the video.